Hello students, in our earlier video we have completed the introductory part of the chapter drawing, the theories of the drawing and the classification of the equipments of the process drawing. Okay, so how we can classify the equipments drawing, like that we have completed, and we have started the equipments also. We have completed our tray dryers and tunnel dryer. Okay, so today we'll study about spray dryer. Now, what is spray dryer? As the name itself suggests, that in this, what is happening, the fluid which is to be dried is atomized into very fine droplets, very minute droplets. Okay, and that droplets are thrown radially, okay, into a hot gas stream. Okay, that atomized fine droplets is being thrown radially into the stream of the hot gas. That droplets is immediately increased and get instantly dried, okay, in the form of spherical particles. Okay, this process usually gets completes within a few seconds, just before the droplets reach the wall of the dryer. Okay, so this is the diagram of your spray dryer. You can see this. In this, what is happening? First, see the construction of the spray dryer. It consists of a large cylindrical drying chamber with a short conical bottom, which is made up of stainless steel. Okay, and an inlet for hot air is placed in the roof of the chamber, and another inlet that carrying the spray disc atomizer is set in the roof. Okay, you can see that atomizer. The spray disc atomizer is about 300 millimeters in diameter, and it rotates at a speed of 3000 to 50,000 revolutions per minute. Okay, and the bottom of the dryer is then connected to a cyclone separator. Okay, so this was the construction. Now, how this works? Drying of the material in a spray dryer, it involves in basically in three stages. First one will be atomization of the liquid. Second step is drying of the liquid droplets, and third is the recovery of the dried product. So what is happening in atomization? The feed is introduced through the atomizer, either by the gravity or by using any pump, means with the help of any pressure or external pressure, okay, to form the fine droplets. Then the properties of the final product depend upon the droplet form, and the selection of the type of atomizer is important. Atomizer is again of various type, like pneumatic atomizer, pressure nozzle atomizer, spinning disc atomizer. It depends upon the type of the product. Okay, then after atomization, what is happening? Drying of the liquid droplets. The droplets which is again atomized is getting dried. How it is getting dried? The surface of the liquid drop is dried immediately to form a tough shell. Then the liquid inside must escape by diffusing through the shell at a particular rate. Okay, so at the same time, heat transfer from outside to inside takes place at a very greater rate than the liquid diffusion rate. Okay, so what is happening as a result of it? The heat inside it mounts up, which allows the liquid to evaporate at a faster rate. Okay, so this is the tendency of a liquid, which tends to rise in the internal pressure, and it causes the droplets to swell. As the shell's thickness decreases, the permeability for the vapor also increases. If the shell is neither elastic nor permeable, it ruptures and the internal pressure escapes. Okay, and third step is the recovery of the dried product. So at the last, we have attached a cyclone separator there. What happens here? The centrifugal force of the atomizer drives the droplets to follow a helical path. You can see this in the diagram. the particles are getting dried during their journey and finally falling at the conical bottom. All these process are completed just in a few seconds. Okay, the particle size of the final product ranges from 2 to 500 millimeters. The particle size depends on the solid content in the feed, liquid viscosity, feed rate, disk speed, etc. Spray dryers of maximum size have got evaporating capacity up to 200 kg per hour. So this was the spray dryer. Okay. Next, what are the uses? It is used in the spray dryers are compulsorily used if the product is a better form than that obtained by any another dryer. Okay. Second one is quantity of the material to be dried is large, and if the product is thermolabile, hygroscopic or undergoes any chemical decomposition. Okay. Now next is, what are the various advantages of a spray dryer? First one is, spray drying is a continuous process and it is very rapid. Okay, so drying process takes place within 3 to 30 seconds in spray dryer. So the labor cost is low as it combines the functions of an evaporator, a crystallizer, dryer, size reduction unit and a classifier. Okay, so these was the advantages. And also, either the solution or the suspension or the thin paste which can be dried in one step to get the final product ready for the package. It is also suitable for the drying of sterile products. Globules of an emulsion which can be dried with the dispersed phase inside and the layer of the continuous phase outside. Now, disadvantages of the spray dryer: it is very bulky and expensive, and it is a very huge equipment, so it is not always easy to operate and clean also. Okay. Third is, the thermal efficiency is low as much as heat is lost in the discharge gases. So this was the spray dryer. Now next one is your FBD, that is your fluidized bed dryer. Okay, in short we can call it FBD. So what happens in this FBD? The hot air gas is passed at a very high pressure through a perforated bottom of the container which contains the granules which is to be dried. Okay, and these granules are lifted from the bottom and it is being suspended in the stream of the air. Okay, so this condition is known as fluidized state. Which condition is known as fluidized state? When the granules is being lifted upwards from the bottom and the granules is being suspended in the air, that is known as fluidized state. And at that time, when the granules are in the fluidized state, the hot gas that is surrounding each and every granule just to complete dry them. Okay, so thus the materials or the granules are uniformly dried. Okay, so you can see the diagram here of the fluidized bed dryer. Okay, you can see here construction is like this. It is made up of a stainless steel and a detachable bowl is placed at the bottom of the dryer which is used for charging and discharging. Okay, the bowl has a perforated bottom with a wire mesh that support for placing materials to be dried. Okay, and a fan is mounted in the upper part for circulating the hot air. Now fresh air inlet, pre-filter and heat exchangers are there connected serially to heat the air to required the temperatures. As the temperature of the hot air and exit are monitored, back filters are also placed inside it just above the drying bowl for the recovery of the fine powder. Okay, now let us see how it works. The wet granules which is to be dried are placed in the detachable bowl. The bowl is pushed into the dryer. Fresh air is allowed to pass through a pre-filter which subsequently gets heated by passing through a heat exchanger. Now what is happening? The hot air flows through the bottom of the bowl and simultaneously the fan is allowed to rotate. Okay, the air velocity is gradually increasing. When the velocity of the air is greater than the settling velocity of the granules remain partially suspended in the gas stream. Okay, it means the granules are in the fluidized state. After some time, a point of pressure is reached at which the frictional drag on the particles is equal to the force of the gravity. So what will happen? The granule rise in the container because of the high velocity gas and later fall back in a random boiling motion. Okay, so this condition is known as the fluidized state. The gas is surrounding each and every granule to completely dry them. The air leaves the dryer by passing through the bag filter, and the entrained particles that remain adhered to the bag is inside the surface of the bag. Okay, periodically the bags are shaken to remove the entrained particles. Okay, so this was your working for FBD. Now let us see what are the uses of FBD. First one is, it can be used for drying granules. It can be used for drying, mixing and granulation process. It can be used for three operations such as mixing, granulation, drying in the production of tablet. It is modified for coating of granules also. Okay. Let us see what are the various advantages of FBD. First, it requires very less time to complete drying. It means 20 to 40 minutes compared to 24 hours of the tray dryer. It is available in various different sizes, 5 to 200 kg per hour. Third is, the drying containers are mobile, it making handling simple, it reduces the labor cost. The thermal efficiency is about 2 to 6 times higher than that of tray dryer. It is also used for mixing the ingredients, and mixing efficiency is also very high. Next is, hot spots are not observed in the dryer because of its excellent mixing and drying capacities. And it can be used either as a batch type or continuous type. It has a high output for a small floor space. And the last one is, the free movement of the individual particle eliminates the risk of soluble material migrating as may occur in the static beds. Okay. Last one is disadvantages. So disadvantages, many organic powders develop electrostatic charges during drying. So to avoid this, electrical earthing of the dryer is very essential. Okay. So the turbulence of the fluidized state of granules may cause attrition of some material, resulting in the production of fines. Okay. So this was the disadvantages of your FBD, and the rest of the equipments we will see in our next video. So this was all for today. Thank you.